All right, so in this video, we want to find this limit as x approaches infinity for these two exponential functions divided by each other over here. And we're also given that k is greater than 0, which is a bit important for this question. So you don't want to do L'Hopital's rule over here because it's going to get more complex. Instead, we know that if we have two bases of exponential equations with the same basis divided by each other, we can actually combine those. And we can combine them by subtracting the exponents. So we have e to the power of kx cubed plus 7x squared minus 12x plus 25 minus e to the 2x cubed minus 8x squared. Oops, no e, sorry. Why am I writing the e again? 2x cubed minus 8x squared plus x minus 10. So I just combine by subtracting the exponents. Then we just want to simplify the exponent. So that's just e to the kx cubed plus 7x squared minus 12x plus 25 minus 2x cubed plus 8x squared minus x plus 10, and then I want to just combine like terms. So lim x approaches infinity, my first terms are just kx cubed minus 2x cubed. You can combine them as well if you factor out the x cubed, but I'm just going to leave it like this. Plus 7x squared plus 8x squared is 15x squared. Minus 13x and then plus 35. So now that we have this over here, we can probably, there's a couple of ways to do this. Let's just think about this for a second. If I sub in infinity over here, and remember k is going to be a positive number that's greater than 0. So we know that if k is positive 2, let's start with positive 2. I know these two terms will cancel out. And if I sub in infinity here, this is definitely going to be positive infinity because I have positive infinity squared and e to the positive infinity squared would be infinity. So I know if k is larger or equal to 2, I know that this limit will approach positive infinity. The only question is if k is between 0 and 2, will it approach the same value of positive infinity? So for example, if k is 1, what will this approach? Well, if I sub in k as 1 over here, I will have 1 minus 2, which is negative x cubed. And then I'll have this whole equation after that. And then, so if k is between 0 and 2, I guess 0 is non-inclusive because in the question it's just greater than 0. If I sub in infinity here, I'll have e to the power of negative infinity because these three will be basically nothing compared to x cubed. So e to the power of negative infinity is basically 0. So between 0 and 2, the function will approach 0 at x approaches infinity, and after k is greater than or equal to 2, it will approach infinity. Now, is there an easier way to represent this? I mean, potentially you could ln both sides, but I think that would require implicit differentiation because if I ln both sides, I'll have, so imagine if I pretend like this is y equals, if I ln both sides, the ln and e will cancel on this side. And I'll just have like the same basic equation k cubed minus 2x cubed kx cubed plus 15x squared minus 13x plus 35. And then I can't really solve this anymore. So technically you can't really do it this way. So I would assume that this is the final solution in this question. Again, I just subbed in values of k between 0 and 2, and then values of k after 2, because you want to basically look at just this over here. And if you factor that out, if you factor out an x cubed there, you'll get k minus 2. So we have to split the scenario into two different things based on k, because here k, my solution for k is 2. I'm going to split it into 0 less than k less than 2, and k is greater than 2. There's two scenarios for this answer, and my minimum is 0. That's why I went from 0 to, oops, that's a 2. K is greater than equal to 2 over here. So if I sub in a k value of between 0 and 2, like for example 1x cubed minus 2x cubed is negative x cubed in my exponent. These will all be insignificant. And if I sub in my limit as infinity, e to the negative infinity is just 0. That's how I got this 0 over here. So the limit approaches 0 when k is between 0 and 2. And when I sub in any value equal to or greater than 2, so 2x cubed minus 2x cubed is 0. Then I just have 15x squared minus 13x plus 35. If I sub in infinity here, I just get e to the positive infinity, which is infinity. If you sub in 3 over here for k, 3x cubed minus 2x cubed is positive x cubed. If I sub in e to that's going to be e to the positive infinity, which is infinity. That's why for greater than equal to 2, we get infinity.